Hello, it's me again. So today, just after work, I decided to come home and I tried out my subtraction machine that I mentioned in a previous video, and I figured it wasn't quite working just right. So I decided to try to investigate it further and come up with a new algorithm to subtract two analog signals from each other in Minecraft. And to produce a sort of like a carry bit. So it's kind of like a full adder, except it does subtraction instead. And if it needs to take a unit from, or a val, take away from the next unit, then it does that also with a carry bit. So it's kind of like a subtraction carry bit. So here it is. The whole thing, it starts with right here, because these are our registers, just as I showed in the previous video. It takes in some A and subtracts B. So right now it's subtracting register A here from register B. Alright, so it takes A in. It does some calculation to A. It modifies A given some circumstances regarding the carry bit. But anyways, A comes through here, right, and it does a whole bunch more calculations, and out comes the result. And so right now it's displaying 14 because what's going on is that, oops, over here we're doing here, let's just reset this here. And we'll start off with new values here. We'll set the carry bit too, so now there's no carry bit coming into it. And we'll just simply do, well, I guess I'll explain this part over here first. This is just the registers, the resets, just like in a previous video where I showed how you can have input to a register and the register providing output here. And pretty much this switch here just says which register to write to right now. That's pretty much it. I just built this so I can have one input over here instead of building two inputs with one with a reverse input, because if I built an input going this way, then one would be over here all the way to 15, but then on this side 15 would be closer, and then one would be over here. So I just wanted kind of a standard input, just so it might be easier to understand what's going on here. So let's first do situations where A is bigger than B, because if A is bigger than B, then we know that we can just simply do the calculation like this. Input A to minus B here, because the subtraction mode here. So if we have, let's say, 15 minus 14, oops, 15 minus 14 is like this. We have 1, and we can do the same thing here with 15 minus 13, right, because 15, 14, 13 goes in, 15 goes in, so it gives us 2, right? So this is the subtractor if and only if B is less than A, or B is less than or equal to A. So this only works if the input B here is less than or equal to the input A. So this is actually in here somewhere that does that kind of math, or that function. And in fact, it's right, let's see, right here. B comes in, goes over here. Oh, no, not here. Right here. There we go. B comes in and subtracts from A. So that's where that is in this whole giant mess right here. So we'll just get rid of this here. Alright, so we'll do those first. So we'll go ahead and let's see, we want to write to A first. So how this works here is just that it's a switch. Subtract 15 from the input. Subtract, well, this is subtracting nothing right now, but over here it'll come down, feed through here, subtract 15 so nothing goes in and it doesn't disturb what's stored in this register. But this side is allowed to pass through and rewrite what's in this register. So we'll go over here and just do a really easy calculation first. 15, and then we'll minus 15. So the same values are going in. And that's wrong. Why? Oh, this is why. Here, 1 second. There we go. 15 minus 15 should be 0. The switch I just flicked is the carry. So the carry pretty much says there's 0 here, so we need to make more room and subtract 1 from 15 to get the actual value of this unit placement. But we'll take that away for now. Have it just at 0. We don't want that on. So we'll do 15 minus, let's say, we want A to be greater than B in these cases right now. 14. We want to write to B, so there we go. 14. So 15, this is 15 minus 14, should give us 1. See, we have 1 light on, or 1 lamp. And then we can do it again, reset it with 13, and we should see 2 lights come on. Yeah, there's 2. Right, and we can test this all the way out if we reset this. If we start at the bottom one, right now it should be 15 because it's 15 minus 0. So if we go 1, it should go down 1 light at a time each time we flick it. And that'll happen each time, you know, all the way through. So now there's another case. So I'm gonna take a break, not a break. I'm gonna go to another window here that I actually used to help figure this out. This one right here, wonderful notepad here. So the function that we made is A minus B, and if there's a carry involved, there's that too. So we have 3 inputs to our machine. Now right away we have this right here. If the carry is set, it's just a boolean, it's just a flag that's saying if it's set. So if the flag is set, then we do this right here. We pretty much rewrite the value of A. And this, all of this right here is inside our Minecraft thing here. This, the teal area over here. So we see the register A here feeds in to over here, and the output comes over here. So pretty much we're rewriting it somehow using this I guess we can call it a function generator of some sort. And right here we have, if A is, we don't really need this, it's not relevant. It's the exact same function generator as over here. I actually made this first because this was more important than the rest of the machine. Once I had this, I was able to make the rest of it because I knew that I could do it. So just like how I kind of broke this machine up into a kind of almost, I actually broke it up into 3 different parts. The orange part is 2 parts in one, but this part I worked on first, which is this whole blue part here. I worked on this first because the value A here in the rest of this pseudocode is dependent on the value over here. So that's why I started there. So to kind of explain this machine here, A comes in, right? Now if A is not 0, here let's do the cases. So we can have that A is, let's see here, A is greater than 0, or A is less than or equal to, oh wait, no, A is just greater than 0. I don't know what I was thinking. So if A is greater than 0, then we just kind of carry the value through here. As you see, this is off. Oh, wait, the carry's on. Gotta take that off. The carry's off, so the value just flows through, comes out here as 15. If it's 0, same thing, flows through, comes out right here as 15. Now if this has value, it flows through, but as you see, it also passes a value through here saying, hey, it comes to, like here, we can see this is one of these subtraction things that we looked at in a previous video. I'll make a quick one right here, where it subtracts 1 from the input. So right here, this produces exactly 1 in the redstone. So it's at the redstone's at level 1, and right here is we have 15, which is subtracting from this one. So 15 is bigger than 14, so it's going to subtract the 15 from it instead of the 14 over here, because it goes 15, 14. Because the 15 comes from here through here, 15, 14, right? And this is on only if the carry bit is off. Now if we set the carry bit to on, it'll turn this off, allowing it to subtract 1. Right? So let's look at that again. So 15 comes through here because there's a value. So A is greater than 0. So here's a repeater that pushes out 15 and pushes it into this block. Pushes out here, causes the 15 to 14. And then since this block is 15, pushes 15 to here, 14, so 15 minus 14 if this is on, right? Otherwise, since the carry bit is off, this turns on, turns this on to 15 minus this 15 here, so the voltage, I guess the voltage, we can call it the voltage, just passes it through to here to the 15. Then again, we have this on, turns this off, which allows it to subtract 14 instead of 15, and so it goes, subtracts 1 from the value of A, which gives us a 14 here. If we carry this back a bit, doesn't matter where, to here even, same thing happens because this repeater here pushes out a completely new value. It kind of refreshes the value up to 15, but the old value from this block is still pushed through this block to this comparator. And right here we have our 13, I think. Yeah, or 13. Now, if we don't, there's another case where we have the carry bit set, but we have no input. Right? So if we have our carry bit if our carry bit is set and A is not greater than 0, we want A to be 15. Right? So what I previously just showed you is that I had the function able to generate that the teal part generates this part. If A is greater than 0, then we want to subtract 1 from A. Otherwise, we want to subtract 15 from A. So in that case, right now we're at 0. That allows this block, since if there's power applied to this block, this torch will be off, right? So if we can look at that, right? Because it just inverts the power of the block here, which then is again inverted again, and which does nothing right now because this torch is on, right? So no carry bit is set, no input is set, so this is off. This right here is pretty much like an AND gate, almost. An AND gate where one of the inputs is inverted, right? So we have an inverted AND gate input right here, it feeds up here, and if we set this, the carry bit to on, we see that it turns this redstone wire on, turns this torch off. So now both of these torches are off. And so this wire is off, which allows this torch to be powered on, which powers this redstone to 15 and passes it through. And we're not subtracting anything because, well, this block has no power, so it doesn't actually turn on the subtractor, the -1 subtractor. So we get our 15. So this teal part generates this whole beginning part of our function right here. It rewrites our A value to the value that we need for this next part right here. The next part right here is, well, as we see here, this register just carries the B forwards into the remainder of the subtractor here. Here's this part. And as I said before, A comes in, feeds in, and here's our subtractor our default case subtractor. So I'll build kind of the part here that kind of encapsulates the important parts of this. Okay, so I need to think about this 1 second. There we go. So an important part to trying to figure this out is we need to figure out which value is bigger first. So we want to use the comparator mode. The comparator, pretty much, we can see it simply this way as a basic example. Let's say we have a value of 13. Oh, we need output, don't we? Compared to another value of 13. And since they're equal, the output is also 13. But if this one's bigger, the output will be 14. Now, as soon as the side input gets bigger than the input that comes in through the, I guess, the main input, the input will be 0. It pretty much tells us that this value of B is bigger than this value of A, the A input. So if B is bigger than A, output 0. Otherwise, output A. So what I built there is pretty much the exact same thing here, except the inputs are fed in this way and compared this way. That way, we can have the same thing, right? Now, there's no subtraction here, but as we see here, we have it right here. We can see this I guess kind of a L shape is same right there, right? I have the subtractor right here. Just right there. The reason for that is that now with this, we actually kind of have one of our conditions met for the whole machine almost. And that is this part right here. If A is greater or equal to B, then return A minus B. We're not actually returning it because we need to, well, we kind of are, but we need to pass it forward still through another function generator which encapsulates this functionality here. But this was the next part that I tackled. So here we are. Let's say they're equal. Value should be even because we're doing A minus B, which is 0. And if we do this, same thing, 0, right? But this should produce a 1, right? There's our 1. And this should produce our 2. Now, you might be wondering what's the difference between what you had before, just the subtractor, and adding this new comparison right before. Well, this adds the functionality that, let's say we have them, they're equal, right? We have this output here that comes out that we can actually feed into another block, which provides some sort of output here. So they're equal, so there's no carry. A is less than B, so there's a carry. A is greater than B, there's no carry. And we can see this right here in this machine, right here. Carry bit's carried upward, lights this block up. So that means our carry bit is set. In fact, I think there's one case in this machine that's not actually fixed here. 1 second. I'll have to look into that and update you guys on that. Anyways, so that was the important part there. Now, this only outputs that one part here, but we wanted this whole other part here, where if it's not, we want to set the carry, get this new value C, and subtract C from 15 and return that instead. Now we're going to go to this part right here first and look at that. So that whole part right here is over here. The setting C pretty much comes out here. We'll just pretend we know how C comes out first, but pretty much A comes through here, and if this is this block is on, then we'll subtract everything from it. So let's try to get that off here. We want to have A to be 14 and B to be 15. So 14 minus 15 gives a remainder of 1. So we might subtract 1 from 15, which gives us our one block over here. Gives us 14, which is correct. But here we see the power comes through here. This comparator, since B is bigger than A, this block isn't on, which means this repeater doesn't turn on, which allows A to pass through this way. Untouched. A is untouched, passing through this way. And through here, what happens is that we actually get our value of C because we're subtracting. Right here, we come through here, subtract B from nothing because there's no value passing through here. B passes through this way and subtracts. And A is subtracted from B instead, which gives our value of C. So if we look over here, we have C is actually B minus A and not A minus B. So we have both of these inside our function, or inside of our machine. And so we have our C gets outputted right here. Now if we recall, if A is bigger than B, we want to, let's see, set that one, set it to 13. So now B is bigger than A. We see that, oh wait, oops. Set B first. Do 14 and 15. Give us 1 here. There we go. So we see over here, pretty much nothing happens here. This doesn't touch it. A comes through unmodified. B comes through obviously unmodified. It's not touched through here. But since B is less than, this block is on, allowing this repeater to block the circuit going this way. And since it's blocked, the output is, A is not subtracted from whatever output this is. And in this case, the output is actually A minus B. And so the output is actually just carried through to this next part here. Otherwise, it would be blocked and minus it from this other value. So we want B to be less than A. There we go. No, I was wrong. Oh yeah, we wanted A to be smaller than B. There we go. So once again, A comes through here unmodified, so does B. But since B is bigger, it doesn't allow this block to be powered on, which then allows A to go through unmodified. But if you look over here, we actually do this block here, which would be powered on in the other case, because the power would go through here and then through here. This repeater is not on, which means that B can simply pass through here and go to this output here. So this output represents both. Let's see. Sometimes these things are just really complicated to remember how they work sometimes. I just built it too. Let's so right here, this is A minus B. So this is A minus B, or just B, right? So it's A minus B in the case where A is greater or equal to B, and it's B if it's B is less than, no, B is greater than A. There we go. So right here, this equals A minus B if and only if A is greater or equal to B, or it equals B if and only if B is greater than A. Oh, there we go. Anyways, so right now as B is being passed through here this way, and so we're subtracting A minus B, and so this right here represents either A minus B or B minus A, depending on the cases that we discussed right here. Now it's A minus B if and only if A is greater or equal to B, and it's B minus A for the inverse case where B is strictly greater than A. Now there's one last thing I had to do to subtract to get the actual value, because in one case we're getting some temporary value C. And C isn't actually, it's important for a calculation here. We can see it's 15 minus C, or it's A minus B, right? So let's see here. We can see here that if A is greater or equal to B, then we set the carry. So we know that if we set the carry, then we're using the value C. As we can see over here, the carry comes up, powers this on. This just inverts so that it can do the proper calculations over here. And so right now we are B is greater than A, so we're in this case right here. So we set the carry, C equals B minus A. Yeah, we already discussed that. Right here, this is the value C right now. So we want to do 15 minus C. So what happens is that this right here, it's powered on because this is not powered on. So this is 15, so it's minusing 15 from this input here, and we know that 15 minus any input on a comparator will output 0. Whereas on this side, the input to the comparator, the main input, is 15, and we're subtracting C from it, which is 1 right now, and then it passes it through this way. So this right here is technically the final output of the whole machine, and it gets fed through here to this display. Now, these blocks are pretty self-explanatory. They're just the stuff that carries the carry signal to the various other inputs here. If you wanted to make a whole another subtractor, a full subtractor, I guess you could call it, instead of full adder. You would add just another one right beside it, and then feed the carry all the way into this side of this one, and you can do that simply with a just like this. You have your input right there, and this works exactly the same. So there you have it. It's a pretty long video, pretty winded explanation of what's going on here. If you find that my algorithm is actually wrong, that could be possible, but the machine should do exactly what this function is doing. If this function is wrong, then my machine is probably wrong. But from the tests that I've done, it works, and it's pretty good. So yeah, there was just one where if it's 0, 0, I don't think it outputs the right answer. We can test that right now with 0, 0, carry 0. Should be 0, but it's putting 15. We can look at maybe why it's doing this. It's this right here. This. And it thinks we have to carry on 0, which is not true. So I would say that's the only thing wrong with the machine, is that 0, 0 wants to carry. So 0 minus 0 says you need to carry, which is false. So that's the only thing that needs to be fixed. I think that's a fairly easy fix. You just have to compare the two inputs if they're 0, 0, and then say, hey, if they're both 0, 0, then don't do anything, which I'll try to do that right now actually. Get a new color here, we'll do lime. Zero, 0. So these are just inverting the signal so that we can have this to be on. No, that's not what we want. If any one of them are on, we want the output to be off. But we don't want to feed it that way. Take this, and do exactly what I just did. Like this. So that's not good because that's powering down this way, which is not what we want. So we might actually have to do a double here. I have to double check that stuff doesn't power it this way. I'll do 15. minus 14. If it goes down to 1, then it, okay, so we're good this way. So that's fine. We can go ahead, put that there. This will feed this way, but it won't. This won't feed through back to the blocks. But we can go up like this, and then another block here. Another block, another block. Now we want to subtract 15 from this if they're both 0. Let's put that down. Now it's at 0. It's good, but we still need to do the rest of this, don't we? There we go. So if any of them are on, then we won't bother with this signal. We can test that out simply by just adding a value to one of the registers. Right, now it's off. We can see that this is not feeding this way. We'll reset this one and test it with the other one. Some other value. A is 13. Turns it on again, doesn't feed through. And we get a value of 13. So there we go, there's the actual finished subtractor. If you see anything else wrong, maybe message me and I'll get on it, try to figure it out. And in fact, this actually kind of works out. This bar here won't actually get in the way of adding another one over here, because there's a lot of space here for the green bar to go down and then meet up with this other input here, because there's a lot of space here. So it doesn't really take up any extra space if you want to put another one beside it, which is good. So there we have it, the full subtractor. Might have been hard to follow along. Hopefully it kind of made sense, and hopefully, you know, I've had it kind of staring, you've stared at it long enough to see exactly what is needed to be done. Once again, kind of referencing one of my previous videos, you can have, you know, store the values in here using some bus that goes this way, timed a certain way so that when the values actually come in, they get locked into the registers, and you can have, you know, maybe up to here. I think up to here would be a full 4-byte subtraction machine, which is 32 bits of resolution, if I did that math right. 8, yeah. So right here, this is just a nibble, one nibble minus another nibble. You'd have to have another one, so a whole byte would be twice the size, subtracting 1 byte from another one. The only downside is that you have to have the nibble of A, then the nibble of B for the lower nibble, and the higher nibble would be right here for the A, and the higher nibble for B would be right here. But I don't think that would be too much of an issue if you have a proper bus running through it. In fact, you can write A and then write B independently at different times if you set it up properly. So yeah, I'm still trying to work on how to get a well-timed bus working for something like that. But that's mostly something that's requires tick management, calculating ticks, or just trial and error. But here we have it. I've rambled on long enough. It is pretty late. The video just passed 45 minutes, so hope this was useful. If you have any questions of how any individual part works, just message me. Thanks, and have a nice week.